done. The next support type that I wanted to show you is the block support, because this is more or less their standard support in AM, let's call it in this way. And for regions like this one, which is not pretty high, which is the expansion is not small, it's a very beneficial way to support. Bigger areas are very likely supported with this block support structure. As you can see here, it's a pretty regular pattern, which you can simply define with the spacing. So in this case, this distance between the walls is 1.6 millimeters in X and in Y direction. You can change this parameter, for example, to 1.4 or 1.4 millimeter. So that you can achieve more stiffness. The tooth pattern here on top and on the bottom by simply changing those parameters. Again, you have an infographic which describes what is the top width, what is the height, and so on. So by simply decreasing, for example, the top width, it's pretty easy to change the attachment to the part, and so you can treat the removal a bit. So the smaller the attachment on the part is, the easier to remove the support is. But again, probably you can run into problems that it's not stiff enough. And the reason why you can treat the bottom and the top pattern in different ways is that the base plate remover, for example, can be harder than the removal onto the part, and this is the reason why they are differently parameterized. And the other thing is that the perforation, which means these diamonds, can also be changed in a way how you feel comfortable. So you can change the height, the width, and all the parameters here. Again, why are these openings or this perforations important? Is once you can save support material, and the other thing is that you stock powder inside the block structure or inside the support structure. And with these openings or with these perforations, powder can be removed easily, let's call it in this way. And one major task that is completely different to competitor software is the smoothing of contour. Normally, we detect the support area based upon the triangle overhang angle. And this will end up in a not pretty smooth contour at the end of the day. I think this can be seen here pretty well. And this not smooth contour leads into some problems. The scanner will scan one single line of the when it's sliced, the support will end up in single lines. And when the corner or the angle between two following vectors is a very sharp one, the laser shifts out of the last vector, makes a movement in the galvo, and starts accelerating and starts melting again. So in this edge, you have a very big temperature overheating potential. And this overheating indicates, again, bending. And it can be the case that this edge will come out of the powder bed and the recoater is damaged. So getting aware of these sharp edges with the smooth contour functionality reduces the scan time, because all these movements which the laser has to do increases the build time. And on the other hand, the tendency of crashes in the supports or with the supports is minimized. I think this is one pretty big advantage of our block support.